similar copies that I purchased to replace it. Living on the farm in Pennsylvania, as I was recovering, I would go out and learn the birds, and I thoroughly enjoyed it. I enjoyed the book so much, it was a book by Howard Zinn. Later, I saw The Golden Nature Guide to Stars by Zinn and Baker, and it also was $1. And this is that book. And believe it or not, that is how I got my start in astronomy. So, your impact on a small gift to a child can be pretty profound. And so I would encourage you to encourage any kid that you ever run across. But anyway, that's what got me started. And by the way, many professional astronomers got started with amateur interest. So I am probably closer to the norm than to the exception. Okay, let me also make an announcement. On September 22nd, there is the Astronomy Day at Guilford Technical Community College. And Mary has already arranged a bus. The speaker is Dr. Roger Windhurst from Arizona State University. And his topic is The World of Webb, Seeing Through the Eyes of Einstein. Now, that may sound pretty complex, but at Guilford Tech, on our Astronomy Day, we've always told the speakers, now listen, this Friday night lecture is designed for the general public. It's not for professional astronomers. So we always tell them, gear your presentation for the general public. And generally they've done a pretty good job. There's a few exceptions, but generally they've done quite well. So if you would like to stretch your mind a little further, I encourage you to sign up for that event. Again, the presentation is at 7:30, and that's on September 22nd. Okay. Before I begin tonight's presentation, I want to tell you some things. I'm going to throw out a lot of big numbers and a lot of big distances. And I'm going to throw them out as if I know what I'm talking about. The fact is, I don't think anybody does. Okay? For example, I'll talk about so many light years and all that kind of jazz. And I think I have a comprehension of the size of the Earth. Because a couple years worth of driving, that would take me all the way around the Earth. I used to drive about roughly 25,000 miles a year, and that'll take you once around the Earth. Now, the distance to the moon, I know that's a little greater. The distance to the moon is about roughly 10 times around the Earth. So, yeah, I think I can comprehend that. The distance to the sun is a little greater than that. It's about 390 times the distance to the moon. Do I comprehend that? I'm not sure. I think the only human beings that have traveled that far are astronauts. So, that's the astronomical unit. Okay? And then there's the light year. Now, I'm going to talk about light years quite frequently. Frankly, I don't think anybody comprehends a light year. I may be mistaken, but a light year, remember I told you that probably nobody but astronauts has traveled an astronomical unit. A light year is 63,000 astronomical units. Nobody's traveled that far. And while I'm going to spit out these numbers as if I know what I'm talking about, don't fall for the illusion that I comprehend it. I don't think anybody does. I'm also going to throw out some pretty big numbers. Now, I kind of think that maybe I can comprehend 1 million. Do I comprehend 1 billion? I'm not sure. Because that's 1,000 millions. So when I talk about billions tonight and so on, I want you to be aware that I'm spitting out these numbers comfortably, but in terms of comprehension, I'm not sure that I or anybody else comprehends these numbers. If you comprehend them, good for you. Okay? So let's take our journey and see what the Milky Way is. It's fun to look up the mythology on the Milky Way. According to Greek mythology, the Milky Way happened because, well, if you recall, Zeus was always messing around and flirting with everybody that he could flirt with. And whenever he found a cute chick on the earth, he had his affairs and so on. Well, Hercules was born from one of these affairs. And according to Greek mythology, Hercules needed some nourishment, and so somebody convinced Hera, Jupiter's wife, to nurse Hercules. But he sucked so hard and so strong that she shoved him away from her breasts. And those of you who've been nursing mothers will well recall that if a little infant gets to sucking hard and gets the milk going, if you shove them away, the milk isn't going to stop. And according to the Greek mythology, what happened is when Hera shoved Hercules away, the milk sprayed out across the sky, and that's the origin of the Milky Way. There is also the legend in Native American culture that there was a fox stole a bag of cornmeal and ran off across the sky, and in the process scattered the cornmeal all across the sky, forming the Milky Way. Well, there's an image of the Milky Way as we see it, scattered across with many images. So where are we in the Milky Way? Well, Herschel tried to figure out where we were. And what he did is he looked up in the sky, pointed his telescope in multiple different directions, and each spot represents a spot where Herschel pointed his telescope. And what he did was counted the number of stars that he saw each direction he looked, and mapped the star count. This is our location at the solar system, and these are, but what do you notice about that? Where are we with respect to the Milky Way? Well, we're very close to the center. But we've fallen into that trap before, because we used to think the Earth was the center of the universe. And then we said, no, it's this. Copernicus came along and said, no, we've got to shift that to the sun. Well, that wasn't correct either, so we had to shift again. So the discovery that we're at the center of the Milky Way, people raised some question about that. And for good reason. So where are we? Well, Harlow Shapley did another measurement. And Harlow Shapley discovered there were a whole bunch of globular clusters. Now, hopefully sometime, perhaps in October, we'll go down to the observatory and I'll be able to show you a globular cluster or two. These globular clusters contain anywhere from 100,000 to a million stars, more or less. And where do you think they should be distributed around? Well, they ought to be distributed around the center of the galaxy. And Harlow Shapley correctly deduced that this is the distribution and that we are out in the suburbs and there is the center of the galaxy. By the way, Shapley had some history here in North Carolina. He was invited down to Chapel Hill. And the people down at Chapel Hill asked Shapley whether it would be better to build a planetarium down there or an observatory. And Shapley's reply was, I'm not sure that the people of North Carolina are sharp enough to use an observatory well. The planetarium is a better deal. And they got so mad at Shapley for that condescending position that they built both. So, yeah, right. Shapley had some conceit on a number of points, but anyway, that's Shapley. But as you see, now instead of being in the center, whoa, the Milky Way, 100,000 light years across, and we're stuck out in the suburbs. So why the previous Herschel view with us at the center? Well, keep in mind, the sky may look very clear to you, but even the sky is somewhat cruddy. And there is enough dust and particles that it actually blocks the view. So we can only see part of the Milky Way. And hence, by doing the star count, he was counting what he could see, but not realizing that there was a lot of it that he couldn't see. So, getting a better perspective on it, what's it look like? Well, this is one of the better representations of what we think the Milky Way might look like. Now, the task is somewhat like, suppose you're in the middle of the forest. You can see trees, and you can see trees in every direction, and you can only see so far. So what does the forest look like? Well, you can see the forest better if you're outside looking in than you can from the inside trying to look out. And that's the situation that we have for the Milky Way. But it does appear, from the best information that we have, that there appears to be a nucleus with kind of a bar structure and various spiral arms around the center. This is our approximate location, and what we see, we can see the next arm in and the next one out. We're located in the Orion arm, and next one out is the Perseus arm, next one in is the Sagittarius arm. And that's about all we can see is this small location. Now that should not surprise you that we're somewhat limited. There are some satellite galaxies around ours. There's various arms and so on. And again, remember that we're out in the suburbs, about 27,000 light years from the center, more or less, and the diameter is around 100,000 light years. So, if you plot all the stars, and I think this is the data from a Gaia satellite that mapped positions, and this is basically a mapping of all the stars that are that have been accessible to us so far. And by the way, there are two small satellite galaxies. If you go to the southern hemisphere, you can see these, and they're fairly impressive sights. Here's an infrared view. Now it turns out that while the dust blocks our view, infrared can penetrate so we can see further in the infrared light. And here is and you see it, there's kind of a plane and a little bit of a bulge in the center. But you notice this particular Z-shaped blue region? Our solar system is tipped with respect to the plane of the galaxy. And there's a lot of dust in our solar system. And this is basically the mapping of the dust in our solar system. So here's the galaxy, and this is the plane of this is the plane of our solar system, tipped with respect to the Milky Way. Viewing it in many, many different wavelengths, different frequencies can look through different things, and that shouldn't surprise you. Have you ever noticed on a very foggy day, you can't see very far, right? Have you ever noticed that you had trouble with your radio or TV? Well, guess what? Those are, just like light, electromagnetic waves. But they must be able to see through the fog and the mist, and indeed they can. Just like on a bad smoky day, you can pick up a radio signal through those, and different wavelengths penetrate far better than others. So on the very top is the radio spectrum. Atomic hydrogen gives off a very specific wavelength, and here's the Milky Way mapped in atomic hydrogen. Here's the radio continuum. There's molecular hydrogen. Here's infrared, mid-infrared, near-infrared. Oh, here's the optical. But there's also X-ray and gamma ray. So in different wavelengths, you get a different perspective. This is a very, very beautiful view of the Milky Way in a radio wavelength. And again, there's the center, and there's some very large columns of gas shooting above and below the center. Now, the Milky Way is a very, very impressive galaxy. And thanks to Tom Brittingham, Tom is sitting right up front, you can get a taste of the Milky Way tonight. When you leave, right in the back, there's a dish of the Milky Way. So Tom says, help yourself before you leave. Okay. To my knowledge, there's no Snickers galaxy or anything like that. Anyway. So is the Milky Way the universe? Is that it? Well, I would suggest that if the Milky Way is the universe, it's a big universe. Because remember, 100,000 light years across, how many stars present? Maybe a couple 100 billion, maybe 400 billion, maybe a trillion, more or less. So if you find it crowded around here, pick your own dozen or so stars and take off and claim your own territory. There's plenty of space out there. Well, is that all there was? I had, until I just gave it to our son Tim sitting up here in the front, I had my dad-in-law's astronomy textbook. It was a classic, still is, from around the early part of the 20th century. And Herschel, with his 60-inch telescope, and many others plotted lots of sights in the Milky Way. And there are a lot of things that are quite irregular and so on. But there's a lot of spiral objects out there, lots and lots of them. And in fact, that early textbook has a gorgeous picture of one of these. They were called the nebula. What's a nebula? A nebula is a cloud. And there were lots of the spiral nebula. So where are they? Well, back in the early 20s, I think it was in the early 20s, there was a very famous debate, the Curtis-Shapley debate. And Curtis argued that these nebula were external galaxies. Shapley, remember the guy who expressed his opinion about North Carolinians? Shapley argued that they were part of Milky Way. I wasn't present. I didn't hear that debate, but I talked to people who were there, and it was very fascinating. The consensus was that, remember, Curtis argued they're external to Milky Way. Shapley said they're part of the Milky Way. According to the people present, they said that Shapley won the debate. Well, I would ask you, what does debating prove? Nothing. And isn't it intriguing how we pick our political leaders? Anyway, perhaps we ought to have a better process. I would contend that debating is not half as significant as doing your homework. And there was somebody else who, instead of debating, was doing his homework. And you've heard of that person, Edwin Hubble. There's a picture from the first night that our first presentation of Edwin Hubble at one of the telescopes up in Mount Palomar. There are a bunch of telescopes. I think that one's on Palomar. It might be on Mount Wilson. I'm not sure. But no, actually, Hubble was working on Mount Wilson. He wasn't working on Palomar. So that would have been at Mount Wilson. I had the privilege to work with one of the telescopes that Hubble worked with. And it was very fascinating because a lot of the greats of the early 20th century worked with the same instrument. And I'm telling you, in that dome, working with that telescope, the ghosts of those old guys is still floating around, and you can practically smell their presence. Anyway, instead of debating, Hubble was doing his homework. So what was he doing? This is the largest and the brightest of the spiral nebula. Okay? Now remember, what do you recall that I said about the diameter of Milky Way? What did I tell you that it was, approximately? 100,000 light years, okay? Now it turns out, in these nebulae, there's a particular type of variable star. It's called a Cepheid variable. The Cepheid variables go through various cycles, and shoot, I forgot her name.
Henrietta Leavitt.
That's right, thank you. Thank you, I appreciate that, Scott. Henrietta Leavitt discovered, in looking at a lot of the Cepheid variables in the Milky Way, that the longer it took for them to go through the cycle, the brighter they were. Now, fortunately, there were a couple of Cepheid variables that were close enough that the distance could be measured by another means. And so they were able to figure out the distance to those Cepheid variables. And what Hubble did when he was looking at this Andromeda Nebula, he found a bunch of these Cepheid variables. But there was something very odd about them. They were extraordinarily faint. Now, what would make a bright supergiant appear so faint? Distance. That's exactly right. So Hubble took the data, and based on their variability and so on, he calculated how far away these Cepheid variables might be. His conclusion, 900,000 light years. So where does that place with respect to the Milky Way? Way outside. Remember, the Milky Way galaxy is 100,000 light years across. So if this is 900,000 light years away, it couldn't be part of Milky Way. Therefore, it must be another galaxy. And if you'd like to read that paper, you can go look up the Astrophysical Journal back in 1923. I think it's the December 1923 Astrophysical Journal. I should have looked it up. But it's online, so you can access it. The American Astronomical Society now publishes all their material, so anybody can get access to it, including my measly little contribution. But anyway, that was one of the more profound discoveries of the 20th century. At the end of the 20th century, they were talking about shaking information that shook up the 20th century, and people had gotten so accustomed to it that they forgot this. But I would contend that the discovery that there were galaxies outside Milky Way was probably one of the profound discoveries of the 20th century. Well, it turns out that Hubble made a mistake. Hubble didn't know, and Henrietta Leavitt hadn't discovered it. It turns out there are two types of Cepheid variables. And if you correct for that, that puts the Milky Way not at 900,000 light years away. The best measurements place it at around 2.5 million light years away. 2.5 million. Well beyond the Milky Way. So, there's not only Milky Way galaxy, there's the Andromeda galaxy. And there are lots of galaxies in the sky. not just a few. And they're very beautiful. When we go down to the Klein Observatory, I hope to let you see a galaxy. Now, don't get terribly excited because remember, it's a long way off. And we don't have the Hubble telescope down at the Klein Observatory. So what you'll see is a little fuzz patch. Ruth's description is perhaps apt. She said it looks like something that may appear under your bed if you haven't swept it for quite some time. So it may only look like a bit of a dust bunny, but when you realize when you look at it that you're looking at light that's been traveling to us for 2.5 million years, that should be a little bit sobering. Galaxies are incredibly beautiful. There are, many of them have this kind of spiral shape, nucleus in the center and then spiral arms. And you'll notice there's different colors. The blue represents very hot stars. The more yellow region is probably older stars. They probably started in the beginning. And you see some of the pink regions where the hydrogen is there. Those are star-forming regions. And there's also dust and gas together make up the star-forming region. Let me show you a few more of the very beautiful galaxies. Well, that's called the Sombrero Galaxy. And you can kind of see why. But an incredible dust lane. I've seen the Sombrero Galaxy, again, not in that kind of detail. There's another very beautiful one. It goes by the classical name of NGC 4414. NGC stands for the New General Catalog. The New General Catalog was developed by Herschel back in the 1700s. But hey, on galactic time scale, it's still quite new. So, anyway. But again, and it's quite common that you see a nucleus, and you notice there's kind of opposite spiral arms. That's quite common. Not all are spirals. There's some that are very elliptical. There's some that are quite irregular. There's a very beautiful one. That's the Whirlpool Galaxy. And if the weather is good, we can see the Whirlpool Galaxy down at the Klein Observatory. Now you notice, whoa, it looks like galaxies collide. And this is probably a collision of two galaxies. And this very extensive image probably are stars that got splashed out in the collision. So what do you think would happen if two galaxies would collide? Would you want to be nearby? Well, I wouldn't care. Because even though there are hundreds of billions of stars in the galaxy, if the galaxies collide, it is entirely possible that the two galaxies could go through each other without a single star bashing into each other. While the stars may not collide, the gas clouds would. And this is probably some of the spray from that. There's an interesting gas cloud outside. In fact, hang on, because we are on a collision course with the Andromeda Galaxy. Most galaxies are rushing away from us. We'll talk about more of that next week. But the Andromeda Galaxy and the Milky Way Galaxy are on a collision course with each other. And it might be a billion years or so before it happens, but it looks like it's bound to happen. And when they collide and go through each other a few times, they may settle down to one big galaxy. Some are very strange, and here is one, M87. Oh, if you see an M number in front, Messier was a comet hunter, and he used to get confused by certain foggy patches in the sky, confusing them for comets. So he cataloged the nuisance objects so he wouldn't make a mistake and call them a comet over and over again. Well, Messier's comets, I don't know that I've heard anything much about them, but virtually all Messier's objects are very fascinating, and that hence the name M87. But notice there's a very bright nucleus, and then there's a jet coming out from the center. So what's going on there? Well, you've seen some other, I don't know, my son who put this together, I don't know if you saw It's a Wonderful Life or not. But apparently that's, I didn't, but apparently that's an image. It's of the Stephens Quintet. And there's a bunch of galaxies. And those probably are about to collide with each other and interact. So what's going on in the center? Well, if we can't see very far, how do we get to the center? Thanks to the infrared, we can see. And these are actual images. And up there you can see the time that the images were taken. Now I want you to watch something, particularly in this small image. Look again carefully, because I'll let it come back. What's in the center that they're going around? What do you see in the center that they're going around? What do you see there at the center? Nothing. Wait a minute. Do those stars, would you think those stars are moving slowly or rapidly? They're very rapidly. Keep in mind, this is 27,000 light years away. To see that kind of motion on that kind of time scale requires very high speed motion. Now, what makes something go so high speed? Must be very strong gravity. And what produces gravity? Mass. There must be something very massive there. Well, if there's something very massive there, it should be very bright. But we're not seeing anything. So what must it be? A black hole. And very recently, within the last decade, I forgot to check the actual time, there's the image of the black hole. And remember, the black hole is a spot where the gravitational field is so intense that nothing can escape, not even light. This was a radio image. It was a consortium of radio telescopes all over the Earth. They basically synchronized them so that it acted as if it was a telescope the width of the Earth, basically, to produce those images. Remember the M87 with the jet? Here's the black hole at the center of M87. Again, an incredible image. So how many galaxies are out there? Well, not only are there galaxies, there are clusters of galaxies. And here's the Hercules cluster. And there was an interesting experiment that was done. Now, if you would like to have access to a really big telescope, if you ask for a time on a big telescope, they'll ask you, what do you want to do? It turns out there are some tenured astronomers. And tenured astronomers are such that they are given a certain number of nights on a telescope. They're regular, so they get to use it time and time again. There was a tenured astronomer who decided to do something that, had he asked for permission, it would have never been allowed. But he asked for permission. He had the time, so he decided to do it. And he pointed the telescope for hours and hours at a spot where he saw nothing. And the result was amazing. So much so that when the Hubble telescope was launched, they decided to perform the same kind of experiment. And what they did, they chose a spot in the sky. It would be about, the size of the spot in the sky would be about equivalent to holding a tennis ball at about 110 yards. So if you held a tennis ball 110 yards away, how much of the sky would that block? Not much. They chose a region where virtually nothing was seen, and they pointed it outside the plane of the Milky Way, because if you shined it into the Milky Way, you'd get a lot of foreground stars. They exposed it for several days. And here's the picture. Ladies and gentlemen, that's a picture of nothing. Doesn't look very much like nothing. Now, again, if you're in the middle of the forest and looking out, you're going to see there's going to be trees in the way. If you're in the middle of the Milky Way looking out, there's going to be a few stars in the way. There's a star. That's a star, I think. There were just a couple stars. But what is the rest? Those are galaxies. Over 1,500 galaxies were counted in that image. A couple 100 billion stars per galaxy. And they tried some others in different directions. And whenever they pointed at nothing and exposed long, that's the kind of thing they came up with. That's a later one. It's called the ultra deep field. Oh, by the way, you notice there's a big bite out of this image? The reason for that is the Hubble camera was made up of 4 basic cameras. 1/4, 1/4, 1/4, and this was especially sensitive, but it was a smaller field. And that's the reason why it has that step. But later on, the ultra deep field, and again, there's a couple of stars in that image. The ones with spikes are probably stars. But virtually everything on that image is a galaxy. So how many galaxies are there? Well, that's pretty amazing. But as amazing as this is, the Webb telescope and the speaker down at Guilford Tech is part of the Webb team. The Webb took the same field there's the Hubble, there's the Webb. If you can comprehend this, my hat off to you. Amazing, that's the only thing I can say. There's that same Webb field in more detail. These are bright foreground stars in the Milky Way. You can tell because there's 6 spikes. That's because there are 6 mirrors on the Webb, and the foreground stars are going to produce that kind of spike. But the my goodness, there's a lot of galaxies there, and quite irregular. So what questions might you have? Yes?
With this mind-boggling number of stars, what's the probability that there are living beings in the universe?
I'm going to address that next week. Yes?
How far away are some of those galaxies? Can they tell at all?
Yes, they can. And I'll also address next week how they measure the distance to galaxies. But they're in the order of 12 to 13. The most distant ones are the little tiny red dots. There's a fairly red one, but pick out a really tiny red dot, and that would be one of the more distant galaxies. And they are probably in the order of 12 to 13 billion light years away. As I told you, I'm spitting out numbers like I know what I'm talking about. Nobody comprehends it. Yes, Joe?
Are there black holes at the center of every single galaxy, or is it possible to have an exception?
There may be exceptions, but I'm not sure that we're aware of any. Probably some of the there are small dwarf galaxies, and I wouldn't be surprised that some of the small dwarf ones may not have a black hole. But the major galaxies, probably most of them have black holes.
Without one, what would keep it together?
Remember that when you have mass itself attracts. So if you have enough stars, they would create their own gravitational field, and the gravitational field itself could hold them together. Other questions? Yes?
The red ones are the most distant because of redshift.
Yes.
Is it possible for there to be stars or galaxies out there that are beyond the redshift?
Probably.
Could you repeat
Possibly.
the question?
Is it possible that there could be galaxies out beyond the redshift that we're not even seeing? And the answer is possibly, maybe probably. Other questions?
What could you tell us about dark matter and where it is?
I'm going to address that next week. Yeah. Will you be here next week? Do you plan to be? Okay. All right. Yeah, I plan to address the question of dark matter next week. I could go into, I want to give you more background before I go into it. So that's the reason why I won't address that tonight. And you remember in the solar system, that little pale blue dot? Us. Anybody who thinks they're big stuff doesn't know what they're talking about. There are a few people that are somewhat conceited in the world and think that they should run things. Well, yeah, if you don't find some of this a bit humbling, I've encountered some top people in astronomy, physics, mathematics. I think I've sensed a level of humility in astronomy that I have not found in other fields. Ruth's observation, I think, is correct, that astronomers are just little kids playing with bigger and bigger toys and wanting bigger and bigger toys. And yeah, because it would be great to have a bigger telescope. It'd be great to have a big telescope on the moon without atmosphere and interference, and may happen someday. I don't expect I'll live to see it, but somewhat humbling, but nevertheless quite interesting. Judy.
I was just gonna say, these presentations, to me, just leave me with the mystery of the universe.
I agree. I agree. We are discovering more and more, but Newton's statement was, if I've seen further than others, it's because I've stood in the shoulder of giants. And I forget whether it was Newton or somebody else said, it's like somebody in the seashore. Every now and then we pick up a fascinating pebble, but the ocean of truth is still before us. Well, any other questions? Thank you, ladies and gentlemen, and enjoy the taste of a Milky Way.